Okay. Hello, everyone. I am Dr. Pankaj Biswas. I am the course instructor of this course. The course name is Welding Application Technology. This course is under the MOOCs program of MSRD. All of you are very well familiar. First of all, welcome all of you. If you have any queries, you can ask me. Okay, one participants, Rohit Kumar Jha, who have written good evening. Good evening, bhai. If you have any queries, you can ask me. Rohit, any queries if you have? Yeah. If you have any queries, you can ask me by writing question here, or you can ask me also after muting what I feel. So first of all, as the name implies of this course, that is Welding Application Technology, in this course, I will try to cover the fundamental overview of the traditional and industrial welding technology, especially those welding processes which are widely used in the field of manufacturing industry that you can observe already, because in this course I have already covered different very important welding techniques which have a wide application in the field of welding. Apart from this thing, this will also help the participant to understand and apply this knowledge of welding in practice for various industrial application. It will also encourage the participants to increase the research interest in the field of welding. That you can observe, because in this course I have covered different types of very well-known traditional welding techniques, details, their principle, their physics, their advantage, drawback, and applications. Apart from these things, in this course, I covered very important topics that is related to residual stress, distortion, and how this residual stress generated in a welding structure. It's, you can say, mechanics. Then how this deformation generally induced or distortion generally induced in a welded structure, that related thing in details I have discussed. Apart from this fundamentals of welding residual stress and distortion, in this course I also discuss how we can measure this well-induced residual stress and distortion. There I have shown different types of well-induced residual stress measurement techniques. There I have shown that the residual stress which we can measure by using generally three different very important techniques. One is called destructive techniques, another one is called non-destructive, and another one is called semi-destructive techniques. So that details actually I have already discussed in this course. Apart from these things, I discuss also how the well-induced deformation, that means distortion, is generated in a welding structure, and how we can measure those distortion. That related details I have discussed. There I have shown how to measure a small deformation of a small structural component to a very large structural component by using different residual deformation measurement techniques. Apart from this thing, at the end, I have also shown actually how to design a welded structure which is subjected to static types of loading. There I have shown once a structure is subjected to what it's called some bending types of loading, some axial types of force, or some you can say torsional types of loading. And if it is subjected to some eccentric loading or combination of different types of loading, then how we can design those welded joint structure, that related things in these details in this course we discuss. So this course is really a very interesting course. And from this course, you will really find a lot of very important information, which is actually required in the field of industry as well as in the field of research. If you have any idea to do futuristic research work, there generally what happens, you can this knowledge from this course will help you a lot. because nowadays you know that lot of research work is going on this well induced residual stress related topics, then what is called then effect of this residual stress on fatigue life of the structure, that related things actually is very much essential topics which will get from this course actually. That's why if you have any plan to do future research like what it's called doing PhD or some other research work, there generally you can find lot of very interesting topics idea from this topics and idea from this course. So if you have any queries, any things in your mind, you can ask me. I will be here for 1 hour. So what happens if you have any queries? So Rohit, if you have any queries, any questions, you can ask me. Fine. Rohit, really, actually, this course is very much interesting course. That what I can say. Because in this course, you will get a lot of information which will be really helpful in your future, you can say, interest that you can see. If you have any plan to do research in the field of welding, you will find application from this course. Apart from these things, you will also find very interesting problem solving related topics, which generally you can arise once you will be in industry. So that's why what happened, these topics is really very interesting topics. Yeah, actually in my means question Excel sheet, there one student asked me that, okay, sir, what are the different types of generally non-destructive types of residual stress measurement techniques on participant task. Actually, as you are the beginning of this course, that's why what happens, you have you have not yet covered those portion, but you will get the information related to this non-destructive testing related topics also. There you will find what are the different types of non-destructive residual stress measurement techniques are there. Then also I am just telling the name of those topics. Generally, XRD is one of the very popular, that means X-ray diffraction techniques. This X-ray diffraction techniques is one of the very popular residual stress measurement techniques. Then Newton diffraction techniques. These XRD Newton diffraction techniques, there is some what it's called ultrasonic vibration techniques are also there. Okay, so these are the different, yeah. Yes, Sagar, if you have any question, you can ask me, right? Sagar?
Yes, sir.
Yeah, do you have any question, right?
Sir, actually, sir, I want to know that, sir, is there any what are the uses in that like data science, artificial intelligence? How we use in like data science? So artificial intelligence, how we use these things in welding?
Very good, very good. Yeah. That is a very good question you ask. Though in this course, I have not covered those artificial intelligence as well as what it can. That means as well as machine learning related things.
Yes, sir.
But what happens? Definitely, if you have any interest in future to know about this, what it's called artificial intelligence and machine learning related things, yeah, you can contact with me personally. I will definitely give you a lot of insight related to those topics.
Yes,
but
sir,
I am just telling little bit about this AI and ML. Generally, this AI and ML you can use in different aspects related to welding.
Yes,
like
sir.
let us, because two of my researchers who is working nowadays in the field of AI and ML, they are the PhD scholar. They are going to develop a, you can say, user-friendly software using this AI/ML. By this, they are going to predict the well-induced defect. What I am telling, and whatever the well-induced defects are there, generally by using this AI/ML, instead of using this manual manpower, they generally directly to see the what it's called images of the, you can say, defect. Directly they can detect what types of defect it is. Apart from so what happens, this will shorten your, you can say, what it's called means time. This will actually improve the means you can say assessment quality also. So this is a very interesting topic. Apart from these things, actually this AI/ML also you can use in what happens quality control of weld bit geometry. Then what happens if you want to predict some uncertainty in your work, because welding is, you know, that is a uncertain types of phenomena. So let's you want to predict what are the uncertainty can be there due to different, what it's called, due to, if you can mute your what it's called because what happens, some noise is coming by Sagar. So what happens, so what I am telling, because welding is a very uncertain phenomena, you know. So what happens if you want to predict the uncertainty of your weld joint, so beforehand you can predict with the help of this AI/ML technique. Like AI/ML technique is nowadays is very popular techniques. Lot of different types of machine learning approach are there. Already people started using those techniques in the field of welding, and different new version of you can see user friendly software types of things are coming, by which you can beforehand you can get the idea what is the effect of different process parameter in your weld bit geometry, weld quality, that means strength. Then what happens, your microstructural features. Then even that AI/ML also you can use for prediction of range of deformation, prediction of thermal history, size of heat affected zone, and all the things. That types of things you can control beforehand with the help of these AI/ML techniques. And actually, you can imagine, actually, during my PhD times also, I use neural network technique. By using those neural
yes,
network.
Sir, actually, I want to also develop that some neural network for developing the different flux. Like most of the people like using trial and error method only. So based on the results, they are changing the composition. So by using artificial network, we can by the what we have data, so we can give to the networks in our by giving that composition, we can get some results. So that I want to develop that kind of.
So what happens? This actually this course is not covering those topics, but if you have any interest, you can directly contact with me. By I am always with you. You know my office mail ID, that is pankaj.biswas@iitg.ac.in. So you just mail me, contact with me. Why? You are always welcome. Whatever the help you want. Generally for this purpose, for artificial neural network, generally I am just suggesting some technique that is called back propagation algorithm. Okay. This back propagation algorithm is a very interesting and popularly accepted artificial neural network, where generally based on your input output interface, you can develop the network, you know.
Yes, sir. Yes, sir.
So that back propagation algorithm have a wide application for your this topic. So you can generally first train that back propagation algorithm with the help of your existing data. Then what happens? Let's now after that, once it will be well trained, then use this network and use your next required data and get the outcome. What I am telling,
yes,
understand?
Once we get the model validated, then we can use for different.
Yes. That you know very good. But back propagation algorithm is a very widely acceptable artificial neural network for this case. Okay.
Yes, sir. Yes, sir.
Okay, Sagar. So apart from this thing, if you want any help, you directly can contact with me, right?
Sure, sir.
Okay.
Thank you.
Okay. Any other questions? Anybody, Rohit? Do you have any question? So I will discuss. Yeah.
Make sir, like in MIG welding, like suppose that feedability is a very big concern in industries. Like in robotic welding, like what where we need to focus for the better like feedability.
Yeah,
like that copper coating or different any we need to add any lubricants like that.
Yeah, that is a very good question. Actually, you see, MIG welding is one of the very popular welding techniques, you can say, which have a wide application in the field of most of the manufacturing sector. You know this thing. It is a generally what types of welding process, you know this thing. It is a generally consumable types of welding process. So consumable types of welding process. So in MIG welding, generally what types of aspects you want to see, whether by using MIG welding, you want to use the MIG welding techniques for thicker section or for thinner section of the specimen. So depending upon your requirement, whether it will be used for dissimilar types of joint, what types of purpose you are going to utilize these things. So based on these things, you need to decide your all other parameters. What I am telling, understand? Like some of the example I am just giving. Let's you want to use this MIG welding techniques for thick section. Because MIG welding technique generally have a limitation of penetration, depth of penetration. So let's you want to increase the depth of penetration of that on that plate using MIG welding process. So for that reason, there are different types of aspects are there. Like one of the aspect like surface active element. You may heard about this surface active element. Sagar?
Yes, sir. Yes, sir.
Surface active element like titanium oxide, silicon oxide, these types of oxide of different means metal. You can some oxides are there that you can use as a surface active element, which generally generate such a force in the well pull zone, which generally increase the turbulence effect, you can say, which increase the depth of penetration. This is one way you can increase the depth of penetration. Apart from these things, some other techniques also are there. Like in MIG welding itself, if you can use what it's called some magnetic assisted setup. Magnetic assisted setup in the sense, like generally what happens during welding process, they develop a magnetic field around the what it's called arc, that you can see wherever there will be a flow of electron or current around the cross section of that. Generally what happens, there will be develop a magnetic field. That magnetic field intensity, if you can adjust, then what happens, you can constrict the arc drastically. Whatever the arc is there, if your constriction of the arc will be more, then what happens, your intensity of what is called arc will increase. Intensity of the arc means what happens, let's some heat is passing in a lower diameter arc, and some same heat if you flow it over a larger diameter arc, then what happens, lower diameter arc will definitely produce high intensity arc, correct? So that high intensity arc also can penetrate, increase the penetration of your this thing. This is one case if you want penetration. Some other case also are there, like what happens, you were asking that okay, whether copper coating and other things, that is different things. What I am telling, and generally in MIG welding, this copper coating is shiny coating is generally used to provide. It has some extra added advantage that you can say. Okay. So apart from this thing, generally you see that without copper coating also you can use this what is called a consumable wire. Why? Because generally in MIG welding process you are using what it's called some consumable or continuous flow of inert gas, correct? Because MIG welding means metal inert gas techniques. That inert gas is sufficient. That inert gas is sufficient to protect the well full from atmospheric contamination. So oxidation and other things you can automatically prevent, right? What I'm telling, understand? So
Yes, sir.
if you want, let's sort of an high deposition rate and high this thing, then what happens? Your flow rate should be increased. Apart from this thing, if you want further improve those quality of weld joint, you can use some auxiliary types of setup where there will be some further supply of some inert medium or some flux also you can incorporate if required. What I'm telling, understand? By this you can protect the weld pool. What I'm telling, understand? So there are different so depending if upon your requirement what you want, based on your requirement you can decide what should be the precaution required for that. What I'm telling, understand, Sagar?
Yes, sir. Actually, sir, like
What you want?
we need uniform feasibility, like in MIG welding. So for robotic welding, so we need without any interruption of car color. So where we need to focus for that?
Yeah, that means feed should be uniform.
Yes,
Correct?
sir.
That you want. That I am just telling. You see, generally, there are two different feeder mechanism are there. One is called constant speed wire feeding mechanism. Another
Yes,
one
sir.
is called variable speed wire feeding mechanism.
Yes, sir.
What I am telling, understand? So
Yes, sir.
constant speed wire feeding mechanism, there we used a very interesting what it's called concept, you can say. That concept is called constant voltage types of power source characteristic. What it's called? Constant voltage types of power source characteristics. There what happens? There generally what happens? I am just little bit explaining. They are generally in constant voltage power source characteristics. I am just explaining this thing by drawing the curve, then it will be very clear to you. So there occur a very interesting types of aspect that is called self-regulation of arc characteristics. What it's called? Self-regulating or self-regulation of arc characteristics. That means if there is a certain variation of what is called arc length is there, then what happens due to this arc length variation, there will be some voltage variation. That voltage variation will, once it will be there, based on this constant voltage power source characteristics, what happens, your current melting rate. So what happens, that's why what happens there, you can continuously flow a constant wire feeding. Apart from this thing, what happens where these types of facilities is not there, there you can use variable speed feeding mechanism. Variable speed feeding mechanism, what is the characteristics of variable speed feeding mechanism? Variable speed feeding mechanism, generally this mechanism use the sense of arc. What I am telling, understand? There is a sensor which generally directly connected with arc. Okay, so if there will be any variation of arc is there, it automatically take the sense of or you can take that signal from this variation and it give to feeder mechanism motor. This feeder mechanism motor generally is a variable speed motor. What I am telling, understand? So
Yes,
as it
sir.
is a variable speed motor, automatically generally this variable speed motor control that feed rate. What I am telling, understand? By changing the speed of the feeding. What I am telling, understand, Sagar? So these two
Yes, sir.
mechanisms have a popular application in the field of what it's called constant feeding of wire. What I am telling,
Yes, sir.
understand, Sagar?
Sir, actually, we have this facility. Actually, we are working on the feasibility test. There is no standard for the feasibility test, but there is some patents like Lincoln, and there are some patents like feasibility test. There is standard for fume test, but there is no standard available for the feasibility. Sir, we are doing like worst condition. Like we are one loop. We are creating one loop of the gun. So by we have a bias on the load gauge, so based on that tip life contact and based on the load what we are doing during welding, we are getting that load is constant, and then only that feedability will be Okay. Otherwise, if load is variable, then that wire is not good for the good feedability. So, like we are testing like that.
Okay. But what happens? This mechanism once you will use, then what happens? You will get that things. What I am telling, understand? Constant
Yes, yes.
feedability. What I am telling, understand? These are the two mechanisms generally popularly used in what is called constant feeding system. That means your well bit geometry will be uniform.
Yes, sir. Yes,
What I
sir.
am telling, understand, Sagar? Okay.
Nowadays, people are interesting this on this context, sir. Basically, MIG welding is using in robotic application, so they need continuous feeding. So in some MIG wires, they are facing uniform, non-uniform feedability, so they are not getting good weld metal, good weld bed. So that's why they are facing some issues. So we are focusing on this to develop like a uniform feeding facility. Hello. Hello.
Uh, Slide with you. Then it
Yes.
will be very clear to you. Then a little bit I'm actually what happens actually. Generally in constant feed types of power source characteristics and constant current types of power source characteristics. Then it will be very clear to you, right?
Okay.
1 minute.
Okay.
1 minute, I think. Little bit I will explain, then it will be very clear. Right? 1 minute, 1 minute. Sharing option is there. Yes. Share the entire screen. Is it visible?
Yes, sir. It's good.
Yeah, it is visible. No? So little bit I am just explaining, then it will be very clear to you. Right?
Okay.
Generally, what happens? This power source. Little bit I'll explain, then it will be very clear to you. 1 minute. Where is the yes duplicate? Yes. Yeah. Generally, there are two types of power source characteristics are there. One is called constant current characteristics power source.
Yes, sir.
Constant current. Yeah. And another one is called constant voltage types of power source characteristic. Correct? These things is well known to you. So in case of constant current types of power source characteristic, what are the things are there? This vertical line generally voltage, horizontal line is current. So here generally this characteristic curves is look like this. You know these things. Whereas in case of this is generally constant current characteristic curve. Whereas in case of constant voltage characteristic curve, what are the characteristic curves look like? Always you should keep it in mind. Generally vertical line is voltage and horizontal line is current. Here this characteristic curves is generally voltage variation is generally a straight line is in nature.
Yes, sir.
That
Flat,
you can
flat,
say
flat.
flat. So here there is a marginal variation is there. Now what happens? There is another characteristics curve is there that is called arc characteristic curve. This arc characteristic curves is look like this. That is very well known to you. Okay. So you see this arc characteristic curve, this is called what? Arc characteristic curve that I am writing. Arc characteristic curve CC. So these are characteristic curves and power source characteristic curves. Where it is cutting, crossing, that point is called working point. PW I am writing. PW means working point. Why it is working point? Because whatever the current and whatever the voltage you will get, that is called your welding current and that is called your welding voltage. This is well known to you, correct? Now what happens in case of constant characteristic curves, generally you see higher the voltage, you can say this is the characteristic curve for L1 length of arc. This is the characteristic curve for L2 length of curve. So here generally if the length increase, then what happens? Your voltage increase. That's why this L1 is greater than L2 here. Correct? So what you can observe here, if there is a variation of, you see this mass of voltage is there, delta V, then in this case, in case of constant characteristic curve, what you observe? Here you can observe that there is a small variation of current is there. What I am telling, understand? Whereas in case of constant, as a small variation of current is there, that's why what happens here, these types of characteristic, constant characteristic curves is popularly used in manual types of metal application, manual metal arc weld, like SMAW and all these types of welding process. What I am telling, understand? Whereas in case of constant voltage characteristic curves, if there is a small variation, you see this is on arc characteristic curve for a particular arc length, there is another arc characteristic curve for another arc length. So in this case, what you observe, if there is a small variation, you see a small variation of voltage, if there is a small variation of voltage is there, the delta V, but here in this constant voltage characteristic curve, there is a huge variation of current is there. What I am telling, under there is a huge variation of current is there. Due to this huge variation of current, what happens? Your burning rate automatically will increase. Heat generation will be increased as well as burn rate will increase, and what happens? Your arc length will regain to its original position automatically. So that's why here generally these heat source, constant voltage types of heat source, power source characteristic heat source is used in automatic constant speed, you can say feed drive system, feeding system. What I am telling, understand? This you should keep it in mind. So this is one way you can control the feeding. That means your deposition rate almost remain constant, that you can say. This is one way. Another way is also there, where what happens, where generally this is your this is your electrode, this is your arc. Now here this is your workpiece. So this is here you are using feeder mechanism. This feeding mechanism is there. Now this feeding mechanism is directly connected to a electric motor. This feeding mechanism is directly connected to a electric motor. This electric motor have a variable speed. What it's called? Variable speed. What I am telling, understand?
Yes,
so what it does, generally there is a sensor which is connected with the arc. So that sensor, once there will be any variation of this arc length, if any variation of this arc length is there, then this sensor will detect that variation. What I am telling, understand? And it immediately give the signal to this variable speed motor. What I am telling, understand? So then your motor will automatically control the speed of this feeder roller What I'm telling, understand? And here generally you can control the what it's called feeding rate, or you can say metal deposition rate. What I'm telling, and you can control the arc length also. Clear?
Yes, sir. Yes, sir.
These are the things generally is required to use, right? Okay.
Yes, sir. Yes, sir.
Okay.
Thank you, sir.
Okay, thank you. Thank you. Any other questions? If you have any other question, you can ask me. Anybody, any question, if you have, you are welcome to ask. That means, Sagor, you are getting interest in welding field. What I feel.
Yes, sir.
Yeah, very good. This topics is really very interesting topics, right? And what happens once you will be in a manufacturing industry, you will find really interest, because most of the problem arise in the field of manufacturing sector only, where welding, this joining technique is the most important technique, right? Okay. That's why this is really helpful topics. After that, I am just going to offer another course in next January that is actually related to what it's called fatigue analysis, thermomechanical analysis of welded structure. Okay, that will be a very very latest research oriented work, as well as fundamental of work. So that course also will be very interesting, right? There I used to generally try to cover most of the aspect related to thermomechanical analysis, then related to fatigue analysis, fatigue life prediction of welded structure, including residual stress, fracture mechanics approach. So different things generally aspects I generally try to cover, and that course also what I feel will be very much essential course who are actually interested in the field of welding. What I'm telling, understand?
Actually, I watch your videos also in YouTube. That 3 years back you taught that like similar to this course only, but there is extra information is available.
Yes. That is the one course that is fundamental of welding science and technology. That course is very that course covers generally what happens, basic principle, physics behind welding, metal transfer, then that welding defect inspection. That course is fully
Hello.
this is the I think 7th time it is running. Then
Sir, you are not audible.
Rekha, hello.
Sir, you are not audible.
Am I audible now?
Yes.
Huh?
Yes, sir. Yes, sir.
Okay, fine. Okay, Rohit Kumar. Rohit Kumar also asks one question. Let's see what he asked. 1 minute. Yeah. So then what we were discussing? So we were discussing like one of the question asked in that Excel sheet. They were asking actually, sir, what are the different types of uh, one questions. Sir, in laser beam welding, which types of laser and chemical used in operation? Okay. Rohit Kumar asked a question, sir, in laser beam welding, which types of laser and chemical used in for operation? Yeah, that is a very good question. Generally, in this course, though I am not covering this laser beam or electron beam types of welding process, these are all, you can say, high intensity, you can say radiation based, radiation energy based welding technique. There are generally two important this radiation based high intensity welding techniques are there. One is called laser beam welding techniques, that is also called LBW, and another one is called EBW, that is called electron beam welding technique. So in laser beam welding technique, generally it that means this laser is a generally light, that you can say. So laser have a full form, you can get these things very easily. So this because it here generally here the light is amplified with the help of some what it's called exciting medium. So from there generally there is generate some photon. That photon generally gain energy with the help of that exciting medium. What I am telling, understand? That high velocity photon, why it generally passing out from the laser source, and that high energy photon, once it hit in a target, then this high energy photon kinetic energy is converted to heat energy. What I am telling, understand? That's why depending upon this speed of this photon, you can say there are different types of what it's called laser are there. Some laser is used for what it's called welding purpose. Some laser is used for cutting purpose. Some laser beam is used for only just sensing of some sensing medium purpose. Some laser is used for direction detection purpose. So depending upon what this intensity of this laser beam, what I am telling, understand, Rohit? Now this laser beam can be developed by different way. Like what happens that because this laser beam can be developed by some solid medium, laser beam can be developed by some liquid medium, laser beam can be developed by some what it's called gaseous medium. So depending upon those medium, generally this laser is categorized in different categories. Like one of the example I am giving solid base laser welding technique, that is called Nd:YAG. Nd:YAG is a very Nd:YAG laser is a solid state laser beam techniques. What I am telling, understand? So Nd:YAG generally here we use some solid crystal, where in this solid crystal it is a composition of Nd and YAG. So Nd, YAG, it is and every term have a name. You can get the things from in details from what is called book. So as this is not the part of this course, then also I am telling. So this is actually is a solid base laser welding techniques. Some other laser welding techniques where liquid is used, that is called dye laser welding technique. What I am telling, understand? So this dye laser welding technique is also there. There are some other welding techniques also, the laser beam you can generate, that is all called gas laser welding process. In gas laser welding process, generally they are most popular. One of the very popular gas welding technique is CO2 laser welding techniques, you can say, CO2 base. What I am telling, understand? Where generally CO2 gas is used to generate this laser beam. What I am telling, understand? So apart from this CO2 gas, with this, there generally we mix some other combination of gas also are there, like nitrogen, argon, and the major composition of the gas is CO2 base gas. So as the light or photon here is generating with the help of some gases, that's why it is called what is called gas laser welding technique. Okay. Now laser beam welding, which types of laser and chemical used in for, so that are the thing. Depending upon your requirement, you can use different types of this laser beam welding process. What I am telling you, it can be what is called solid state base, it can be gaseous base, or it can be liquid base also. What I am telling, understand?
Yes, sir.
Rohit is typing. Yeah, Rohit, yeah, you can ask. But what happens if you want more detail about laser welding related things? I have a video lecture on this, as well as I have a PPT document. Though this is not the part of this course, if you want, I can share with you. Right? Yeah, this ruby laser also is there. This is a solid state laser, right? Okay.
Thank you.
Very good. Okay. So if you want, I can show you this ruby laser detail also. This it will be better. I have the PPT of all these things. If you want, I can share also you this thing. Little bit I am just checking just here itself. I am right now. I'll show you. Okay. LBW. I'll laser. I'm just downloading this thing and sharing with you how the ruby laser is working. Just I'll share it to you right now. I have downloaded the things and now I am going to share these things with you. That will be better. So detailed information is given here in this. So I'm sharing this thing. Yes. One minute. Yes. I'm sharing this screen, then it will be very clear to you. So this is the where it is. Enter skin. Here you can see. Though this is not the part of this course, then also I'm just showing. Here you see. I'm just making it full screen.
Yes.
So is it visible? This is the lecture on laser beam welding. This is my lecture only. I'm just showing what are the different components. You see everything, what are the laser properties are there, what are the different component of a laser beam are there. You can see this is the things I have shown. Okay. Then after that, generally what is the difference between laser light and ordinary light? Then what is the how the laser is generated? Okay. After that, I am just showing this detail step is given here. Okay. Then here I am just showing your ruby laser, principle of laser beam welding. Here you see the chromium atom of ruby laser are excited and pumped into. Have you observed this thing? So this is generally ruby laser setup also I am showing. Okay, this is the ruby laser setup in right side. You can you see these things?
Yes, sir.
This is the ruby laser setup, how it is developing, what are the power source required to generate this laser beam, and what is the lens system generally we use to generate this focus this laser beam as per our required location. Everything in details is provided here, right? Okay. So you can get the things. I have also shown here laser welding. What are the different mode of laser welding techniques are there. Then here I have shown, you see, there what are the type of different laser, type of laser use. I have already told you gas laser. This gas can be helium gas, neon gas, carbon dioxide gas, nitrogen gas, cadmium gas. You can see. Then liquid laser, generally it is also called dye laser. Okay. Then solid laser. Here the one of the popular laser is called ruby laser. What I am telling, understand that you can observe there. Yes. Okay. So everything's are there. So here generally for different laser, what is the range of wavelength? What is the generally uses of these different laser in what purpose? Everything is given here. Laser welding related here. Helium, carbon dioxide, NDX laser, fiber laser. Okay. High power diode laser also are there. So these are the different laser related things, and its detail also is given. Then process parameter of this laser beam are also there. Laser beam welding techniques are there, like power, traverse speed, spot size, power density, that is called irradiations, then linear heat input. So every aspect. Then what are the advantage of laser beam welding? What are the drawback of laser beam welding? Disadvantage. Where is the application generally? Which types of material generally we can use this thing very popularly? So laser, you can imagine, can be used in ceramic, glass. So lot of very high melting point alloy like titanium alloy, nickel alloy. So lot of application nowadays of this laser beam are there. And this laser beam welding techniques also not only using welding purpose, it is also used for cutting purpose also. Okay, so this is the topics I have. If you want, you just mail me. I will share this document with you, right? Okay.
Okay, sir.
Okay, everything is with me. Whatever the things you want. So from the scratch to very high fundamental level, actually, laser related information I arrange in this lecture note. So if you want, I can share with you. Just you mail me, I'll share it with you, right? Okay, any other queries, any things if you have, you can ask me. Any other queries? So the last question actually which was asked, I was discussing those things. That means what are the, you can say, different types of non-destructive residual stress measurement techniques are there. I have already told you one is called XRD technique. Another one is called neutron diffraction technique. So generally XRD techniques is mainly used for measuring the residual stress on surface level within around 50 micron depth range. Whereas that neutron diffraction techniques you can use for high depth thickness residual stress measurement purpose. What I am telling, understand? These are the things you should keep it in mind. So these are two very popular non-destructive techniques. Residual stress measurement techniques are there. But what happens, these techniques generally have a very high cost, because in XRD techniques, what we used to do, we generally used to measure the what it's called crystal layer distance. Whatever the crystallographic layer is there, that layer distance generally we measure for a residual stress sample and without residual stress sample, how the crystallographic distance between two layers are there. Based on this distance variation, we generally used to predict the what is called residual stresses. So for that, generally a very interesting principle we use, an interesting law we use, that is called Bragg's law. That related things you will get within very few weeks, because after this very initial very few week, these are the topics will come. So there you will get the detailed information related to those two measuring techniques. Okay. So if you have any other queries, you can ask me. I think no further queries are there. So Rohit, Sagar, if you don't have any queries, others also, if you don't have any queries, I have seen that there are no further queries in YouTube also. As you don't have any queries, so what we can do? Yeah, Chandra Mohan, sir, in which residual stress measurement technique strain gauge are the placed at? Yeah, that is a very interesting question. I have already told that is generally is a strain base, strain release base, what it's called residual stress measurement technique. It is a generally you can say central hole residual stress measurement techniques. What I am telling, understand? So in central hole types of residual stress measurement techniques, central hole based drilling techniques, where generally we place the strain gauge who's 120 degree apart from each other. What I am telling, understand? Thank you, Chandra. If you have any other queries, you can ask me. I think no further queries are there. So what we can do, Rikha? Hello? Hello? Yeah, I think no further queries are there, by. So what we can do, we can stop today, actually. Yeah, that will be better, right? Shall I leave? Yeah, thank you.